Hi friends, in my previous video I had told you about Raleigh's theorem. Now we will understand one more important theorem used in calculus called Lagrange's mean value theorem. Lagrange's mean value theorem states that if a function fx defined on closed interval ab is continuous in closed interval ab and also it is differentiable in open interval AB, then there will always exist at least a point between A and B such that the differentiation of function at that point will be equal to FB minus FA, that is value of function at B, that is value of function at upper extreme of the interval, minus FA, that is value of function at lower extreme of the interval, divided by B minus A, uppermost value of interval minus lowermost value of interval. Now we will understand the physical significance or physical importance of this theorem. Say y is a function of x and we want to plot a graph between y and x, and say the graph comes out to be of this shape. If this point is say A, such that for this point the value of fx is fa. If this point is marked with capital A, then coordinates of capital A will be a fa. In the same way, say somewhere here it is a point B, then for point B the value of function will be FB, and corresponding to point B, point on curve is marked as capital B. The coordinates of capital B will be B comma FB. Now if we understand what is FB minus FA, FB minus FA will be change along vertical axis, and what is B minus A? B minus A is corresponding change along horizontal axis. So it means this is B minus A while this is FB minus FA. So what is change along vertical axis divided by corresponding change along horizontal axis? This will be the slope of straight line passing through points A and B, and a straight line cutting the curve at two different points is called secant. So the right hand side of this expression, that is FB minus FA upon B minus A, will give slope of secant AB of y versus x curve. Now if this slope of secant is equal to f dash c, then what is the differentiation of function with respect to x? Differentiation of function with respect to x physically represent the slope of tangent to y versus x curve, and if f dash x represents general expression for slope of tangent to y versus x curve, then what will be represented by f dash c? F dash c will represent the slope of tangent to y versus x curve at that point for which value of x is c. Since c is lying between a and b, then it means in between a and b always there will be a point at which tangent to the curve will be parallel to the second, and here it will be the point at which tangent is parallel to the second AB. So this point will correspond to x is equal to c. Similarly, for this second curve, there can be 2 points at which tangent to the curve will be parallel to the second AB, and these 2 points, the first one somewhere here and the second point will be somewhere here. So there will be 2 values of c for which the tangent to y versus x curve will be parallel to the second of the curve passing through points A and B. Now we will understand how we will verify Lagrange's theorem for a given function on a given interval. So this time the function given is fx is equal to x minus 2 sin x, and we have to verify Lagrange's mean value theorem for this function on interval minus pi to pi. To verify Lagrange's theorem, first we will understand whether this function is continuous or not for closed interval minus pi to pi. Since this function is the sum of 2 functions, one is a polynomial function and another is sine function, and we know that polynomial function as well as sine function both are continuous for all real values of x. Hence the sum of 2 continuous functions will also be continuous. So first thing, the fx is continuous for closed interval minus pi to pi. Now second thing, x is polynomial function which is differentiable for all real values of x. Again, sin x is differentiable for all real values of x. Hence difference of 2 differentiable functions will also be differentiable. Thus the function fx will be differentiable for open interval minus pi to pi. If these 2 conditions are satisfied, then we will have to find a value of c within the open interval minus pi to pi for which f dash x, say that point is c, then f dash x at that point, that is f dash c, should be equal to f upper limiting value of interval, that is pi, minus f lower limiting value of interval minus pi upon pi minus minus pi. So we will have to find out the value of c satisfying this condition, and if Lagrange's theorem is true, then we will have to prove that the c is lying between minus pi and pi. That is, if c will be lying between minus pi and pi, then Lagrange's theorem will be verified for this function on closed interval minus pi to pi. Now first, what is f dash x? F dash x will be 1 minus 2 into differentiation of sin x will be cos x. So this implies f dash c is 1 minus 2 cos c. If this equation is 1, then from 1 f dash c means 1 minus 2 cos c is equal to f pi, means pi minus 2 sin pi, minus f minus pi means minus pi minus 2 sin minus pi upon pi minus pi, that is 2 pi. This implies 1 minus 2 cos c is equal to pi minus 2, and value of sin 180 degree is 0. 2 into 0 minus pi means plus pi, minus plus, but sin minus pi will be minus sin pi, so it will become minus 2 sin pi is 0, so 2 into 0 divided by 2 pi, and this implies 1 minus 2 cos c is equal to 2 pi upon 2 pi, implies 1 minus 2 cos c is equal to 1, implies 2 cos c is equal to 0 or cos c is equal to 0. Now what will be the values of c satisfying this equation? Those values of c which are lying between minus pi and pi and satisfying this equation will be minus pi by 2 and pi by 2, and these two values will be belonging to closed interval minus pi and pi. These two values are belonging to closed interval minus pi and pi, and these two values are the values of c. So there always lies at least one point between minus pi and pi for which f dash c will be equal to f pi minus f minus pi upon pi minus minus pi. It means the Lagrange's mean value theorem is verified for function fx, because c, that is minus pi by 2 and pi by 2, are lying between minus pi and pi. Now we are taking one more example in which we have to use Lagrange's mean value theorem to prove b minus a sec square a less than 10b minus 10a less than b minus a sec square b, where 0 is less than a is less than b is less than pi by 2. Here we will take the function of x, y is equal to 10x, that is fx is equal to 10x, and the interval on which this function is defined is closed interval AB, where 0 is less than a is less than b is less than pi by 2. It means the values of a and b are lying between 0 and pi by 2. We know that between 0 and pi by 2 the function 10x will be continuous. So first thing, tan x is continuous for closed interval AB. Also, tan x will be differentiable within open interval AB. On open interval AB. Now we will find out a value of x lying between A and B, for which f dash c will be equal to fb minus fa upon b minus a. This implies, what is f dash c? First we will have to find out f dash x. F dash x means dy by dx, and dy by dx will be sec square x, because differentiation of y means differentiation of tan x with respect to x will be sec square x. So f dash x will be sec square x. So f dash c will be sec square c is equal to fb. Fb means tan b minus fa. Fa मतलब tan a upon b minus a. It means sec square c will be tan b minus tan a upon b minus a, because c is lying between b and a. That is, as a is less than c is less than b, sec a, sec c, sec b. It means if angle will increase, then cos of the angle will decrease, and sec is 1 upon cos, so sec of the angle will increase. This means if sec a will be less than sec c will be less than sec b, then it means their squares will also obey the same relationship. It means sec square a will be less than sec square c will be less than sec square b. Now sec square c can be replaced by tan b minus tan a upon b minus a. So it will become sec square a less than tan b minus tan a upon b minus a, which will be less than sec square b. Multiplying this inequality by b minus a, we get b minus a sec square a less than tan b minus tan a less than b minus a into sec square b. And it was to be proved. Thus, using Lagrange's mean value theorem, we have got the required result.